Okay, welcome back. Now the example I'm going to work is number 2, and it's on page 354. So number 2, page 354. Let's get a better marker. Okay. This example talks about taking numbers, writing them on pieces of paper, putting them in a bag or a hat, and randomly picking them. And so what we start off with is a universal set. The universal set is the set of all possible outcomes. And this one is listed as the numbers from 3. Oh, I can't find a good marker here. Let's see if we can find a fresh one. 3, there we go. Which one's worse than the last? Here, let's see. So we have 3, 4, 5, 6, 7, 8, 9, and 10. Okay, that's the universal set. Now you'll notice that there are 8 of the outcomes there. There's the cardinal number of the universal set here is 8. 1, 2, 3, 4, 5, 6, 7, 8 numbers, 8 cards, 8 possible outcomes. Okay. Now we look at some events. Event A is a prime number is drawn, and event B is an even number is drawn. So the first problem it asks us to solve is, what is the set of outcomes described by the prime numbers? Okay, well you have to know about what prime numbers are. 3 is prime, 4 is not, 5 is prime, 6 is not, 7 is prime, 8 is not, 9 is not prime either, it's equal to 3 times 3, and 10 is not prime. So that is the set of outcomes in the set of prime numbers that are possible to be drawn. Okay, now let's look at the next one. What are the even numbers? This is a lot easier because we're familiar with even numbers. It's 4, 6, 8, and 10. And that's set B. Now it asks next that we draw these in a Venn diagram. So I'm going to erase this and draw it in a Venn diagram. It's pretty easy to see that all these numbers will fit in one or the other except for one number. Okay, so let's keep that in mind. I want the numbers from 3 to 10 in my universal set. This is my universal set U, okay? And I've got 2 sets in here that don't have anything in common, A and B. A is the set of prime numbers, okay? That was 3, 5, and 7. And B is the set of even numbers, 4, 6, 8, and 10. And the only one left out is the number 9. Number 9 is not prime and it's not even. So we'll make sure that's in the screen here. Okay, pretty good. Let's zoom in a little, make it a little bigger. Hopefully that's easier to see. Let's go a little bit bigger there. Okay, there's my Venn diagram of the universal set and the other sets, A and B. Okay, now the next question, this is the answer to part C. D asks, what's the probability of A occurring? So the probability of A occurring is going to be the number of outcomes in A divided by the number of outcomes in U. So this is easy enough. I just count them. I've got 3 outcomes in my event. And as we saw before, there are 8 possible outcomes. So 3/8 is the probability of that happening. Now, you don't have to turn that into a decimal. In fact, I think it's probably better not to. In some of these fractional cases, just make sure your fraction is expressed in lowest terms, and you can leave it that way. There's no need to express it as a decimal. If you've got a nice fraction, like 3/8 is a nice, easy to deal with fraction. Let's go on and look at E. We'll look at the probability of B occurring. Okay, it's just the same way. I count up the number of outcomes. There's 4 there. There's 8 total. So in fact, this has a probability of 1/2. Meaning there's just as likely to draw an even number as it is to draw an odd number. There are as many evens as odd. If they're randomly chosen and all equally likely, then the probability of an odd number is 1/2. Okay, see how that's doing on the screen? And pretty good. Let's get it, whoops, over a little bit. Give me some room on the right. I think I might be able to squeeze the next one in over here. Let's look at the answer to F. Now F asks, what's the probability of A not occurring? Well, that's the complement of A. That's not A. So what's the probability of not drawing a prime number? Let's see how the book phrases it. It says, What's the probability of A? Now that's what we already figured out. That's D. Let's see. We want the probability the number rolled is composite. F says composite, not a prime. So if we know the probability of the primes are right here, to get the probability of the not primes, I have to count them up. These are all the composite numbers. 1, 2, 3, 4, 5. So there's 5 of them and 8 total. So the probability of a composite of not a prime is 5 out of 8. Okay, G asks us, what's the probability? All right, the phrasing it uses is, what's the probability that the number rolled is odd? Okay, well that's not even then. What's the number rolled is odd? Well, let's count up all the odd numbers. 1, 2, 3, 4. There's 4 out of 8. As I mentioned before, that's 1/2 as well. It's half that it's going to be even, half that it's going to be odd. And what you start to see here is one of the things that we get, that is that the probability of the event and its complement must add up to 1, because one of them is going to happen. So the probability of one or the other happening is exactly 1. One of them is going to happen. Okay, G we did. Now we're going to look at H. H asks us to find the probability that the number rolled is both even and prime. Okay, so let's write that out. We want the probability that it's even and prime. Okay, that means I want the intersection of these two. I want the probability of A intersect B. And, it almost looks like an A there. Well, there is no intersection. They don't overlap. There's no even prime numbers in here. 2 is an even prime, but that's not included in here. There are none of them, so this probability is 0. You're never going to get one that's both even and prime. If it's an even number, it's outside the prime circle. If it's a prime number, it's outside the even circle. So that can't happen. All right, that's 0. All right, now let's look at what happens in I. In I, we're asked, what's the probability of a number rolled that's either even or prime or both? Well, they're not going to happen that it's both. So here we're looking at the probability of A or B. And so for that, I just add up all these numbers. 1, 2, 3, 4, 5, 6, 7. There's 7 of the 8 numbers that are either or prime or both. None of them are both. So it only leaves out that one. Okay, that is the answer to I. Now I need some room. So let's make some room. I'll get rid of some of this. I'll leave the Venn diagram so we can use that to answer our other questions. And we'll go on to the next question. The next question is J. And J wants to know, verify that PA prime is 1 minus PA. Okay, well let's verify that. We already figured out the probability of A prime. So what we're going to say is that the probability of A prime should equal the number in A prime divided by 8. Well, the number in A prime is the number outside that circle. So that's 1, 2, 3, 4, 5 out of 8. All right, now basically what we say here is that 1 minus 3/8 is equal to 5/8, and so that verified it. But if I take 1 minus the complementary probability, I should get the original probability, and vice versa. Okay, let's move on to K. What happens in K? Well, in K we're asked, verify that PA union B and so forth. We want to verify this set equation. So let me write it out here. P, probability of A union B, probability of A plus probability of B, minus probability of A intersect B. Okay. Now I just figured out the probability of A union B. We figured out it was 7 over 8. What we're going to do is verify this numerically. So what's the probability of A? We figured that out before. The probability of A was figured out in part D. That's 3 over 8. And we're going to add the probability of B. We figured that out in part E. That was 4 over 8. And the probability of A intersect B was 0. So we get 7 over 8 here. That is, in fact, what we found for the probability of A union B. So that's K. All right. Now I need some more room. So let's erase. And the good thing about the video, if that was too fast for you, just stop it and go back and you can see it again. Now we're going to look at L. What's the probability that it's odd or composite or both? Okay, which means it's the probability of odd. Well, that's B complement, or composite, that's A complement, or both. Okay. So I want the probability of B complement union A complement. Okay. Well, that's not too hard to do when I look at B complement and A complement put together, right? Well, actually, maybe it is a little difficult to do because if I look at the complements, they kind of overlap each other. B complements everything outside of B, A complements everything outside of A. I want to figure out what's the union of the two of them, all right? Well, in fact, what we're going to find out is that the two of them paint the whole set when I look at their composites. The probability of odd or composite or both is that everything in here is odd or composite or both. All these numbers are odd, and all these numbers are composite. So the probability of them being odd or composite or both is 1. And let's count up y. Well, B complement, the probability of B complement, look what's outside of B. That's 4 over 8. What's the probability of A complement? That's what's outside of A. That's 5 over 8. And what's the probability of the intersection? A complement intersect B complement? That's the ones outside of A that are also outside of B. That's 1. It's the outcome here down at 9. That's the intersection of the complements. So we put them all together in our formula. We're going to get 4/8 plus 5/8 minus 1/8. And that's 9/8 minus 1. That's 8/8, which is 1. So it's certain to be prime or composite, or both, right? Because nothing in here is a composite and prime at the same time. Let's make sure that it didn't go outside the screen. We got a little bit outside the screen there. Let me move it down and we can see what's going on there. Sorry, I got outside the screen a little bit there. Maybe we'll zoom back a little. There. Okay, almost done. That was L. We're going to look at M and N and then we'll be done. So let's look at M next. All right. M asks, what's the probability the number rolled is either odd or composite or both? Odd or composite or both? Well, that means it's the probability of odd, which is B complement, or composite. No, I think I just did that one. I must be reading it wrong. Prime probability number is either odd or composite or both. I think that's what I just did. Now, in L, I should have done what's the probability the number rolled is both odd and composite. So actually, I did them out of order here. This one is this. Odd and composite. Odd and composite. Both odd and composite. Both odd and composite. Okay, that's both. So actually, this is the one I did there. So now, what's the probability they're both odd and composite? Okay, so where does it overlap? I already did that down here. The overlaps of the intersections here is this one outcome 9. That's, well, let's just call it 1. I just have 1 over 8. One outcome out of the 8 is odd and composite. Okay, last one. Let's look at N. What does N ask? Well, N asks us to verify that probability of A union B complements is probability of A plus probability of B minus the intersection. I already did that here. So I guess I already did that. All right. Maybe what we don't need to do is build it up from the beginning. What we're seeing here is what I mentioned in words, is that everything in here is either odd or composite. None of them are both. So I'll say C over here. All right. That concludes this problem. So now you can see how we use our set theory that we learned in the first 4 sections as we go forward into probability. We're going to be counting elements in sets. We're going to look at complements, unions, and intersections going forward.